Viewers and subscribers, good morning. A wonderful morning here in Jamaica. And, I want to say welcome back to my YouTube channel. So, today we want to destroy this circuit here. We want to destroy this series and parallel circuit. As you can see, it look very complex, very, very difficult. And, just looking at it, it could bring a headache, right? Especially when they ask you to find certain values and all of that. But we are here to really help you guys to understand these kind of things and let you know that these things are, not as hard as it seems. It's all about the technique. It's all about how you go about calculating these kind of things and the know-how, because it is a set way how to calculate these kind of things. And once you follow that procedure, then you cannot go wrong, and you can tackle any circuit in the world. Before going further, please remember to hit that subscribe button and to like, share, and leave a comment. Let me know what you think about this video. Any adjustment you think I should make or whatever, any recommendations, let me know in the comments below. Anyway, we're gonna get straight into it. So what we wanna do with this big guy right here, we want to cut him right into. We want to cut him in two. We're gonna separate it so things can be broken down much nicer for you guys to understand. Now, I've shown you guys this video, this circuit in a previous video when we were discussing how a series and parallel circuit work. Please see that video. If you have not viewed that video yet, please view that video before you watch this calculation. Alright? But just to retract some of it a little bit, remember that the current will be flowing from this direction here. From this is the battery, a DC source of 12 volts, and the current will be flowing from this side of the circuit, and it's going to go around, come down here. So I'm going to come down here through this resistor here, and so I'm going to go out to these resistors out here, and come back around right back to the source, and we'll be calculating some values. We'll be finding the individual currents, and we'll be finding the total resistance right here at Green's Electrical School. Please stay tuned. Okay guys, so first and foremost we want to find the total resistance of the circuit. Now I want you guys to pay attention how these resistors are connected. This resistor is connected right here. It is independently connected, and what the worst thing, it is different from many series and parallel circuit, because many times you would have had the series resistor come first. A good example is I've drawn a circuit. This top circuit, this circuit at the top right here. You'd have seen the resistance series first before you get to the parallel circuit, but it's not so in this case. You have the independent parallel resistor first connected, which gonna make this circuit a very unique way to calculate. And I really want you guys to get along with this one. All right, so we're gonna go ahead and find the total resistance, okay, which we are looking for is RT. Please, if you it's best to get a copy of this circuit or draw it before we go any further, because I'll be erasing some section of this circuit because our little whiteboard is small. Okay, so here we go. We're gonna find first the resistance total, which means RT. Okay, now to find RT, we're gonna have to break this circuit down into small sections. So what I'm gonna do, I'm gonna calculate this resistor right here by itself. This resistor right here, this R1 resistor, because it is independently connected, we're gonna calculate it first. Here we go. So we're gonna name that resistor. We're just gonna call it, we're just gonna call it R1, because it is by itself, so it is not really connected, really with in any group per se. So we'd say R1. We're finding R1 first. Would have been equal to 8 ohms, and it's as simple as that. Okay. So next we're gonna move on to this parallel group first. It's always good to work out your parallel group first, then you attack your series group, because these two resistors are in series, but these two down here are in parallel. So we're gonna work out those next. So we're gonna name them our parallel 1. Okay, our parallel 1, which will have been equal. The values of these resistors are 2 ohms each. Alright, so we're going to use the formula, a formula for calculating resistors in parallel, which is very simple. We would say those two resistors are R4, so R4 multiplied by R5 over R4 plus R5, which is going to equal, we're going to plug in our values now, equal to 2 ohms, right? Multiply by 2 ohms over 2 ohms, right? You know, my ohms are not drawn so perfectly, but you guys know what it means. Plus 2 ohms, right? Which is going to equal to, 2 times 2 is 4. And it will be 4 over 4. So, or RP1, so therefore we could say RP1 would have been equal to 1 ohm. Yes, because 4 divided by 4 is equal to 1 ohms. Am I correct? Yes, I am. So we'd have found the resistance here, and we'd have found it here. So we're going to go to the next section now. Remember we're dividing this circuit into smaller sections so that we can understand it better, right? So we're going to do this section now, the series group. And what I'm going to label them as R series or RS, okay? And to find the total resistance in a series circuit, we would say, all right, it would have been R2 plus R3, which would equal to, we're going to plug in our values now, 4. Okay, you can forget the ohms for now. 4 plus 3 would have been equal to 4 and 3, 7. Would have been equal to 7 ohms right here. Okay, beautiful. So we get that. So now we have the value of the resistance that is here, and the resistance that is here, and the resistance also that is here. Now we're going to point out something very, very important at this point. It is very important to note this, viewers and subscribers. We're going to point out something very, very important. Now, normally, when you're calculating a series and parallel circuit, and you have gone in and find the resistance of the individual groups, whether the parallel group and the series group, and the parallel group again, then normally you would have converted that circuit to a series circuit, just like I've done here. Normally, when you have a circuit like this, series and parallel, when you find the individual resistance, you convert it to a series circuit, then you add the resistance. Now, this case is very different. That's why I have to make a video on this one, because in this case it is very, very different. We are not going to convert it to a series circuit because of this resistor right here. This resistor is independently connected in parallel, right? You don't have no resistors before it, like the circuit that I've shown you. You don't have a series group first. You have a parallel group. You have a parallel resistor first that is independently connected. So what that means, this resistor is in parallel with everything on this side. So it means that once I find the total resistance on this side, I'm going to have to calculate it in parallel with this resistor in order to get the total resistance. Trust me, you have to do it that way, else you're going to run into problems. All right? So please, copy this and get it, ensure you have this together so you can move on. I'm going to show you exactly how I'm going to do that. Okay, guys, so we're going to calculate now. Now we can calculate the total resistance. We're still looking for RT. We don't reach there yet. We're gonna find it. Here we go. So RT would have been equal to, watch this now. RT would have been equal to this resistor right here, R1, being that it is independently connected, R1, and it is in parallel with this group over here. So it means that I'm going to have to add all of these resistance values together. And remember, we just found them. We find this one to be 7, and we found this one to be 1. Okay? So we add them together, and we're going to name them. We're going to name these set of resistors over here. We're going to call them R parallel 2. Okay? So we're going to say, okay, R1. We're going to use the same parallel formula. Please, viewers and subscribers, I have a next formula we use to calculate parallel circuits in the next video. Please, if you have not seen that video before, parallel circuits, please do view it so you can see the next formula. But this is a very simple formula for calculating two resistors or two loads in parallel. So what I would say, R1 multiplied by RP2, yes, we're going to call that RP2, over R1 plus RP2. We're going to plug in our values right now. And this circuit is getting very easy right away. You can feel that sensation that that good feeling, you know you're on the right track. So it would have been, after you calculated 7 and 1 is 8, so it'd be 8 times 8 multiplied by 8, right? By 8 ohms. Let's put in the ohms there. And 8 again plus 8. So now we're going to calculate that and find out what that value is. So that would have been equal to 64, right? Over 16, right? So therefore our answer, if you could calculate that, our answer, okay, so our answer RT would have been equal to 64 divided by 16. You would have got 4 ohms, right? Am I correct? You would have got 4 ohms. So therefore, there you have it. RT uh, would have been equal to 4 ohms, viewers and subscribers. Now, for part 2 of this video, we will be doing the individual currents. I'm going to show you the exciting facts of how the current flow. Please check out my next video on part 2 of this circuit. It is excellent, and it's very easy to work to. All right, so see you in the next video.